Welcome. I'm going to make a little video to show you how to do the velocity graph on this because some people were having trouble with it, right? So once you have your data, and I totally made up data here, okay? Once you have your data, you're going to have to calculate velocity, and we're going to do it differently than we've done in the past. And these are the instructions that I asked you to use, okay? So just quickly to look over it. Scrolling down. All right, so a reminder, you should do it using consistent time intervals, right? All right, and then you're going to make a graph of position, or we're calling it displacement, versus time. With time on the horizontal axis. And then you're going to make a new column called velocity with appropriate units. So to show you how to do that, all you had to do is like go here, actually go here and do insert column on right. That's how I did that. And I made a velocity column. So then, scrolling down here. All right, this is the key part. So we're going to do a curve fit, and you're going to select linear, even though it's not a linear function. Okay, and then we're going to unselect data points until we're only using the smallest number of data points to get a slope. We're just going to use 3. All right, and then you're going to use that slope to find the velocity. So let me show you how you're doing that. So I configured my graph, and the way you do that is you just kind of come in here and say what you want this to be. So I put time on the x-axis, and I put displacement on the y-axis, and you can see I got a curve, okay? But for the purposes of calculating velocity, we're just going to use a linear curve. All right, there, done. And as you can see, that doesn't match very well. So then the next thing that we suggest doing, that they say to do, is to deselect points until you just have 3. So I'm going to select this one and deselect all of the others. All right, so now the only things I've selected are the first 3. So what we have is, it's not quite the slope of the tangent, but it's the slope of the first 3 points, which is pretty it's a pretty small window. All right, and then if you scroll down, it gives you the equation of the line. I learned this as y equals mx plus b, and what's in front of the t here is the slope. So this is 30. Notice they've even put the unit in for you, 30 meters per second. So then I'm going to scroll up here, and I'm going to skip the first row. And the reason I'm skipping the first row is we're using all 3 points here to get the data. And this midpoint is the one that it's most accurate for, right? So we don't really know what this value is, so I'm just going to skip it. So at point 2, I'm going to go ahead and record 30 meters per second. And notice I'm just leaving this blank. All right. Then what I'm going to do is come down here to my graph, and I'm going to unselect this guy. It's not easy to do with this window in there. And then I'm going to select this, and you notice the slope goes up a little bit. It's slightly higher. Now it's 55. So I can scroll up and put 55 under 0.3. And again, what we're doing here is the midpoint is the one we're recording data for. And then I'm going to unselect this and select this. It gets a little steeper. And for 0.4, I'm going to record 85. And so on. All right, I'll do a couple others. And we're up to 100. And again, I made total random data. All right. I guess I'm going to do the whole thing. So let's see, unselect, select, and we're up to 125. And then unselect, select, and whoops. And we're up to 150. And let's see, one more, 2 more. Unselect, select, still 150. And then I get, let's see, goes up slightly, 175. And you can make the argument you shouldn't do the last two, but I'm going to do the last two because it's more accurate than nothing, I guess. So 200. Now we've got all our velocities, and now so what you're going to do is reconfigure this and now make this a velocity graph. So I'm going to change this to velocity. Done. Now, look at this funky thing. And now I need to reselect all these points that got erased in the last bit. And turns out that my magical sample data that I made sure worked is a linear curve, as it should be. And then you can look at the acceleration of this curve by looking at its slope. All right, and clearly my sample data, I don't know, unless we're on Jupiter, not Jupiter, something big like, oh no, Jupiter or something. Or like this is half the acceleration due to gravity of the sun. But yeah, so that's the idea. Buena suerte.